Again, my name is Jason Vandiver, Energy Code Program Manager for Spear. A little bit about myself real quick before we get started. I've been with Spear for about 5 years. I like to joke that I'm a recovering building official, 5 years clean, no red tags issued. So I'm, now I grew up, my dad's a carpenter, so I grew up framing houses in the Dallas area. So I've worn the tool belts in the Texas summers. Doesn't take too many of those to realize I'll maybe spend some time in an air-conditioned office. And so I did the city inspections for about 10 years. And then now I joke that I'm a tree-hugging hippie working for an energy efficiency nonprofit, which is part of the reason why I feel inclined to cover this energy code overview. And just some housekeeping real quick on Zoom. If you aren't familiar with Zoom, you can make my face go away. You can make it bigger or smaller or get rid of it completely. There's a bunch of options in your top right-hand corner that you can deal with that. And you can, and yes, I will send everybody a PDF copy of this presentation. And as well, I will send that Word doc of the basic mechanical permit and inspection guidelines. I will make sure Miranda gets a copy of that to get to everybody. And then also I have, and at the end of that document, there's a bunch of hyperlinks that if we have time at the end of the presentation today, I'll show you guys a bunch of resources that are really helpful going forward. And all of those hyperlinks will be in that document as well. So I'm happy to share all this material. And if I mention something that doesn't come across in the presentation or you need some follow-up on. The nice thing about working for Spear, we are an energy efficiency nonprofit, and so any way I can help y'all out going forward, please don't hesitate to ask. The price is right, it's always free, and I'm always happy to help. I mean, that especially energy code related stuff, but having been a building official, I'm happy to, hey, a plumbing or electrical, any question, I'm always happy to answer. I'm a bit of a code nerd. One nice thing about working for Spear is that it affords me the ability to do some research, and I mean it's a very building sciencey type job. It allows me to kind of get into the weeds on some of this stuff, and so always happy to help. Don't hesitate to reach out. So again, we're going to cover this residential overview, and then we will move on to that basic mechanical permit inspection guidelines. So who is this company Spear that I work for? Well, we're one of 6 what's called a REO, or Regional Energy Efficiency Organization. Basically, back before DOE had its funding cut, we were somewhat minions for DOE. We plan their annual Energy Codes conference. We apply for and get grants from them to do research projects. I've done a pretty interesting HERS rate or variability study. We've done some data studies. In the 10 o'clock presentation, I'll talk more about an energy code field study we did in Texas that had some really interesting results. But basically all things Texas and Oklahoma related to the energy code, we're the folks to call. And if the nice thing about it, if I don't know the answer, having worked for Spear for 5 years, for example, I had a building official email me the other day and said, hey, we had a house being built and I go to do the final and it's foamed. Well, the homeowners changed their minds after they started and went to foam, and he goes, but the cornice guys evidently didn't get the memo and they put in a ventilated soffit. Can I have a ventilated soffit with a fully foam encapsulated home? And you go and you start doing the research in the code. Well, you have to have an air barrier at that top plate on a fully foam encapsulated home. Like, well, foam, open cell foam qualifies as an air barrier depending on manufacturer at about 3.5, 4 inches. So that should be fine. But I couldn't find anything specific in the manufacturer's literature, or certainly the code didn't cover that. But working for Spear, I just happened to know the vice president of the Spray Polyurethane Foam Alliance and emailed him. And 15 minutes later, he's like, oh yeah, that's in SPF Bulletin 119. And so I was able to email the building official. He had that document in his building file. 15 minutes later, again, price is right. Always happy to help, no charge. So again, we will get to that basic mechanical permit as on the agenda, but we're going to do a little bit of background on energy codes and state law first. And then it's really helpful to understand the compliance pass. That's one of the most confusing things about the energy code. One of the smartest inspectors I know, he's probably on the call this morning, Jeff Adams, just a sharp dude, really sharp dude. And he'll call me every once in a while, and it's over confusion over these compliance pass. And frankly, it's just because they make it so stinking complicated because, oh, wait, hold on, there's R6 duct everywhere. Yeah, but you can have R6 if you show the trade-offs in the calculations. And so understanding ResCheck, and ResCheck does trade-offs, but it's through the prescriptive total UA calculations. And so they make it as murky as muddy water, and it's really tough to understand. And it's, your ducts, for example, can leak as much as they want. If you're doing the performance path, then you show the trade-offs, and it doesn't really make sense. And on the total UA, even worse. I can make your building thermal envelope comply with R5 in the walls and R13 in the ceiling, as long as you have a bunch of really good windows. And yeah, that doesn't make any sense, right? That house is going to be an energy hog. So I'll try to unmuddy the waters of the compliance pass, and that will be important, and it'll help you differentiate as when you're doing your real estate inspections, understanding if you primarily work in climate zone 2. So if you're, San Antonio, Central Texas area, Houston area, down on the coast, that's all climate zone 2. Well, there's a different baseline mentality to think about building thermal envelopes and energy code if you're in climate zone 2 versus if you're in the DFW area, up in the Panhandle, any of the North Texas areas. Those are typically a performance path area. So understanding the trade-offs there and things to look for there certainly is going to be helpful. So we'll look at that. We'll cover, no matter which path through the energy code, there are a dozen items that you have to have. So if you're doing an inspection and one of those mandatory items is missing, I would certainly call it out. And then we'll cover a little bit of HVAC sizing and ventilation at the end of this presentation. There will be a repeat in the 10 o'clock section, just because those are two of my big pet peeves, HVAC sizing and ventilation. And so we'll cover that pretty much at length. And then of course, we'll save some time for questions. So I used to give that. So back when I started for Spear 5 years ago, House Bill 1736 just came into being. And basically, I'll cover more on the law here in a second, but I was given a lot of presentations for HBAs, and then I was, this is climate zone 2. So this is the Central Texas and Houston folks, and I'll show the climate zone map in a minute and talk about how that works. But basically, long story short, yes, it is more expensive to build a home to a more modern energy code. This table right here shows the cost of going from the 09 to the 15 energy code is about $2,000 a house, you see here. Well, that's gonna, if you finance your house on a 30-year mortgage, and this is on about a 2,000 square foot house, so you're gonna raise your mortgage by about 10 bucks a month, or you're going to save $18 a month in your utility bill. So from the first month of the energy code, you are actually generating positive cash flow. So it's, builders used to complain, oh, people aren't going to be able to afford these houses. Well, is a house more affordable if a mortgage is $10 more and a utility bill is $20 less? Yes. Obviously a house is $10 a month more affordable. And that's for the life of the home, So a lot of these things just make sense. And when we look at the prescriptive tables, you'll see that the 2015 energy code, these aren't passive house standards. This isn't an R60 wall. This isn't an R100 ceiling. This is a very doable R13 baseline wall for climate zone 2, again, Central Texas, Houston, R20 baseline wall for DFW and North Texas, but you can trade off that R20, and again, on the compliance path section of this, we'll talk about that. And don't worry, we'll save plenty of room for that basic mechanical code permit inspection guideline. So how did all this come to be? In the 2015, so basically back in and under the Health and Safety Code, Section 388, gives Texas the ability to adopt statewide energy codes. And all of this came actually from the 70s, the Clean Air Act, from, hey, we started noticing our cities and our air becoming really polluted, and we didn't want to look like the air quality in the big cities and in some of China and India and some places where there's lesser regulations. And so that Health and Safety Section 388 came into being, and it gives what's called SECO, which is our State Energy Conservation Office. They have the authority to examine and recommend for adoption and into the legislature energy codes. And in the 2015 session of the legislature, House Bill 1736. So basically what happened is the tree hugging hippies like myself and the HBA, actually we kind of came together and got with the legislators. And I'm sure y'all are all well aware that the ICC publishes their residential code and their plumbing code, and all of their codes, they're published every 3 years. Well, the builders were tired of that 3-year, right about the time they're figuring out the new requirements in the code, a new one comes out and there's all these new requirements. And so the builders agreed to that they actually got on board with House Bill 1736, but part of the stipulations of that was that SECO couldn't look at another residential energy code for 6 years. So that is coming up this fall. The 2021 IECC will be published, and after publication, Texas A&M's Energy Systems Laboratory will have 6 months to review it for stringency. And then SECO will or will not make a recommendation to make that the residential energy code. But for real estate inspectors, this date right here is crucial, this November 1st, 2016. So if you're looking at any house that was built in 2017, then well, if it was CO'd in the early part of 2017, it possibly could have been permitted before this. But certainly any house built in CO'd in 2018 will have been permitted. It's actually September 1st, 2016 for residential and November 1st, 2016 for commercial. So residential is what we're talking about here. So you can say for certain that by state law, that home should have met the 2015 energy code. So these items that we highlight and that we identify today in this presentation, you can say with certainty that by state law, any of these deficiencies would have been applicable. So that's why it's important. So again, we already covered this. I'm not going to go over that. And actually state law requires, oddly enough, you can go inspect all the electrical you want. You can inspect framing all you want, the structure and the framing all you want, no license required. I mean, we know that, like I'm a licensed state plumbing inspector. You have, the Texas State Board of Plumbing Examiners, if you're out doing plumbing inspections or plumbing work, there will be an enforcement agent coming to write you a ticket pretty quick, pretty substantial fines. Well, there's no fines through the State Energy Conservation Office, but just interestingly enough, plumbing inspectors and energy code inspectors are the only two things that by state law have to be code certified. And so, yeah, that comes straight out of, this is a snippet of state law requirements that code certified inspectors shall perform the inspections. And there's more and more, if you're not busy enough as real estate inspectors, if you need a little side gig, you're not busy enough, man, you can get your Building Performance Institute infiltration and duct leakage certification pretty, in a week. Seriously, it's pretty easy. Now going through ResNet and getting certified as a rater is a little more expensive and a little more exhaustive of training. But if you just want to get a blower door and a duct blaster and get that BPI IDL certification, and then $180, you go take your ICC residential. It's a combination certificate that covers residential plan review and inspections. And voila, you can do energy inspections and testing. It's now, I would highly recommend you ride with an experienced rater for a day or two to just kind of learn some tricks of the trade. I'm sure I know one of the presenters yesterday, Stephen Reinhardt. He's a good guy in Central Texas that he knows the rating and inspection business well. But a lot of municipalities have turned this over to third parties completely. The cities don't do the inspections. And so there's a pretty robust business as far as that availability to get into that business. And technically, you know, as a building official, and I tell building officials this all the time, if you're allowing a third-party inspector to do the inspections, you know, straight out of the code book, you know, chapter 1, under the administration chapter, hey, you need to be approving these people. And you know, the word approved is actually in italics, and any word that's in italics in the code book means that goes over into the definition chapter. So you have to be approved, which is in the 2012, it said, basically alludes to the fact that the building official has examined your licenses and criteria and that you are able to do those inspections. So let's move on to the compliance path part. So basically, the way the energy code works, there's multiple ways through it. And so in any builders, there's no window to wall ratio requirement. I mean, just, you know, you can have a whole bunch of windows as long as it's traded off with other building components. You can have 20-foot ceilings. You can have, I mean, there are no hard no's in the energy code. You just might have to turn in performance calculations showing that what you want to build meets the energy code. And so basically the way the code works is there's prescriptive items. And so you'll go through the code in a code section, right after the title of the code section, maybe it's 402 point, let's see, what's service water heating? 402.3. And then it'll say mandatory or prescriptive in parentheses. And so what that means, and all of those sections that say prescriptive in parentheses, all of those mean that if you are following the prescriptive path through the code, that those items have to be done. And then there's also, after various code sections, there's the word mandatory in parentheses. And that is regardless of code of compliance path, those mandatory items have to be done, period, no matter what. And then there's what's called performance requirements, and that's going to be section 405. Those basically, think about performance as you're going to put your inputs into some software. You know, maybe I'm doing an R15 wall, R38 ceiling, 0.25 solar heat gain coefficient, all of the, and then you also, the difference between performance and the res check is in performance, you're going to put your service water heating efficiency, your heating, ventilation, and cooling efficiency. So it takes into account the electric used for those items, and then how those impact, how that building thermal envelope impacts that electric use. And as long as the house you want to build is going to have a lower or equal to electricity cost of the house built to the prescriptive numbers, then that's how you pass the performance test. And I'll show you the prescriptive numbers, and we'll go into more detail on all this. And then the last way is through ERI. You can think, it's not quite identical, but you can think of ERIs as being synonymous with a HERS score. I'm sure all of y'all have heard of HERS raters. That's the home energy rating. Oh gosh, home energy rating. Anyway, the HERS score. Y'all are familiar with HERS raters and the HERS score. So that's basically the ERI path. The simulated performance path, it would be, there's free performance calculation software through IC3. Texas A&M Energy Systems Laboratory has what's called their IC3 performance calculator. Takes about 30 minutes to input a non-difficult 2,000 square foot house into the software. And then a lot of y'all hopefully are familiar with ResCheck. So ResCheck is a total UA prescriptive calculator. And that's what makes it difficult, because in climate zone 2, you can follow a straight prescriptive path, or maybe you might have R30 in the ceiling instead of R38, right? Well, hey, you can't have R30 because prescriptively you have to have R38. No, that's not necessarily true, because the total UA prescriptive, which is what the calculations that ResCheck does, ResCheck basically allows trade-offs through building components. So it's going to ding you for if you go R30 instead of R38, you will get dinged, so to speak, R8 for every square foot of attic insulation that you're R30 instead of R38. But you can make that up through better windows. You know, you've got 40 square feet of really good windows, that might make it up. And so basically, U factors are inverse of R factors. So it's just basically 1 over R is the U factor. And what ResCheck will do is it adds all those components up, and as long as the building thermal envelope trade-offs meet those prescriptive, are equal to the prescriptive numbers, well, that's how you pass on the total UA path and ResCheck. That's a free calculator as well. ResCheck does those calculations. And we'll go into more of all of this. It's just kind of wanting to lay the groundwork and the foundation of there's really kind of the 5 options, because there's the U factor table. And so I kind of think of it as one of 2 ways. I think of it as prescriptive, and I think of it as either the tables or the ResCheck. So either of these 2 are prescriptive. But when you think about trade-offs, you're not thinking about service water heating and HVAC and energy costs. You're just thinking about building thermal envelope trade-offs. And then there's software calculations, which are these 2. So there's kind of 2 ways through it, and we'll talk more about that. So what's all this based on? When we look at prior to September 1st of 2016, when the 2015 Energy Code became state law, the 09 Energy Code was state law then. So even if you're looking at a house built in 2014, well, the 09 Energy Code was the minimum required by state law. So we're looking at, in climate zone 2, this is the Central Texas, Houston area. See if I got a climate zone map. I'll show you a climate zone map at the end. Basically, you're looking at a line, it's just south of DFW is that climate zone 2 line. The Fredericksburg-ish area is climate zone 2, just north of that's climate zone 3. And then up in Amarillo and the Panhandle, we actually get into climate zone 4. I'm guessing we don't have too many people on the call today from climate zone 4 and in the Panhandle, so we're really just going to talk about climate zone 2 or 3. So whether you're doing those ResCheck calculations or the performance calculations, these are the baseline that the software is looking at. So we're looking at in climate zone 2, and let's look at climate zone 2 and climate zone 3, these 2 columns, and kind of compare them. So ceiling, right, is the same. Well, this is the big kicker right here up in the DFW area versus the Central Texas and below area, right, is this baseline wall. Well, if you're looking at new residential construction, builders don't like to do 2x6 walls. Well, that's, unless you're using closed cell spray foam, that's what you have to do, right, to get an R20 in the wall. Or you can do an R13 wall, and then if you see any plus numbers in these tables, that always is continuous insulation. So an R13 wall with an inch or an R5 continuous insulation. Those are the baseline calculations that ResCheck and the performance software are going to compare it to. Or if you wanted to just build a straight prescriptive home and not have any trade-offs, you can do that just fine. You don't necessarily have to turn in a ResCheck. You just need to have all of the minimum prescriptive requirements denoted on your plans, and you can turn those in, and it shouldn't be a problem. Now, you put all those numbers in ResCheck, it's going to show you pass, so that's just kind of a way to prove that you met those requirements. But needless to say, plenty of builders in DFW are still using 2x4 wall, and they're not using that 1 inch of continuous insulation. I mean, putting an extra inch on top of the sheathing, That a lot of times that's going to mess up your brick ledge. It throws off your concrete guys. They have to go from 2x6 to 2x8 brick ledge boards. The bucks and the window installs. That extra inch of foam can mess up your framers on the window installs. It's not that difficult, but if you don't have the skill and you're not used to doing it that way, it can really create some problems. So most builders, even in the DFW area on a brand new home, I mean, I get phone calls all the time. Hey, they didn't meet that R20, or it doesn't have an inch of continuous insulation. Well, that's okay. Now most of the time, you're going to have like an R15 bib, a blown in blanket insulation is what a bib is. It'll have like a net on the wall, and they'll fill it full of blown fiberglass to get to about an R15. Excuse me. Because again, for every square foot of wall at R13, if they wanted to just do the cheap R13 bats and a 2x4 wall, well, they're going to be penalized R7 for every square foot of wall, because the baseline in climate zone 3 is that R20. So they're going to have to make it up somewhere, right? And so that's why they typically will go to an R15 or go to those performance calculations. And that's also why spray foam can meet code, because right, it's like, well, shoot, I've got 6 inches of spray foam on the roof deck. You know, depending on manufacturer, you're looking at about R20 to R24. Well, R24 is nowhere near R38, right? So you're getting penalized R14 for every square foot of ceiling. Well, you might only have R13 or 14 in the wall with spray foam. So you're getting penalized R6 for every square foot of wall. Well, how in the world is that house going to meet the energy code then? Well, the reason it can meet the energy code, it'll never meet the energy code if you're using a res check in climate zone 3. It just won't, because res check doesn't take into account the HVAC savings, right? Because all res check is concerned about is your building thermal envelope. But think about, I'm sure all of you have been in a home inspection where you walk up into the attic and it's a fully foam encapsulated home and it's August in Texas, and you're a really happy inspector that you get to spend an hour or two in that conditioned attic. Those are great days when it's 80 degrees in the attic instead of 130. Well, the rim rate software and the Ecotrope software, there's 4 or 5 others that do those performance calculations. Like I said, IC3 is a free one. Well, all of those realize that, hey, this in August in Texas, this piece of equipment in the attic, that, one of the dumbest things we do in Texas is we put our piece of equipment responsible for generating cold air in a 135 degree attic, right? Like dumb, but we're saving every square foot we can. But what those performance softwares do, and the biggest bang for your buck that you can do in building a home, is getting your mechanicals into conditioned space. And so they can take into account the tremendous savings you will realize by having your performance calculations in conditioned space, and they're able to factor that in, and that's how you're able to comply with the energy code with 6 inches of foam on the roof deck when the baseline requirement is R38. Floors, R19, we don't have a whole lot of floors in Texas, but just keep in mind, if you're doing that bonus room above the garage or whatever it may be, that floor insulation, not only does it need to be R19 in climate zone 3, you're okay with R13 in climate zone 2, but it has to be in constant permanent contact with the subfloor, right? It can't just be laying on the drywall on top. You typically, on a final inspection, you're not going to see the U numbers and the solar heat gain. For those of you that don't know what this is, basically, the U factor is the thermal transmittance through the door, basically how efficient it is. And then the SHGC, that's the solar heat gain coefficient. For U factor, basically the lower these numbers, the better. So the lower the U, the more thermally efficient the window is, and the lower the solar heat gain. Basically, a solar heat gain of 0.25, what that tells you is when the sun is shining directly on that window, 75% of that solar radiation energy is being rejected to the outside, and 0.25 or 25% of it is coming through into the home. So needless to say, up in North Dakota, you want a higher solar heat gain coefficient, right? Because it's a predominantly heating dominated climate. You want, when the sun is shining on the window, you want like a 0.6 or higher up in climate zone 8. Well, down here in climate zone 2 and in climate zone 3, we're looking at a 0.25 or lower. And think about if you're building your own home and you were going to splurge on good windows. Well, maybe you don't want to splurge on good windows throughout, but maybe you've got a west-facing wall on the house that doesn't have good shading from trees, doesn't have a good porch overhang. Well, maybe you want to spend a little extra money and get maybe a 0.17 or 0.15 solar heat gain coefficient on those west-facing windows, whereas you've got a 12-foot porch overhang and north-facing windows. Well, if you've got a 12-foot porch overhang, the sun's never going to be shining in that window, right? So I would just be looking for a minimum code requirement, 0.25. But if they're north-facing windows, maybe I'll spend a little more and get a lower U factor to help keep that cold from coming through as easily. So that's what that U factor and solar heat gain. And again, you can trade these off. These numbers can be monkeyed with, so to speak. But there's a mandatory requirement in code that the average of these numbers have to be these or less. So it will not let you just trade these off all you want. Now it will let you, if you're following the straight prescriptive path, for example, there's a 15 square foot exemption. So maybe you tore down grandma's old barn house and there's a 2x2 piece of stained glass or something that you want to put in over the kitchen sink. Well, it allows up to, 30 square feet of door and 15 square feet of window, I believe, that don't have to meet these requirements. But if you're doing the res check or the performance, then you will put in just what you're installing. I had a question from the city of Granbury just yesterday about this hot water pipe insulation. The 2012 energy code was a little more stringent on that. Basically, for a real estate inspector, what I'm looking for on a final on the hot water pipe insulation is if I have a circulation system, well, then one of the mandatory requirements, so regardless of compliance path, one of the mandatory requirements is R3 insulation on my hot water piping. So if you see that circ system and that hot water piping is not insulated, I would certainly write that up because that is 100% a deficiency. Talked about the compliance tools a little bit already. Energy gauge out of Florida. RIM rate is the predominant one being used right now. Actually, Ecotrope just entered the marketplace a couple of years ago. This is the free one I mentioned, the IC3. ResCheck is also free. It does that prescriptive total UA calculation. And again, we'll look at the mandatory items here in just a second. So what does a ResCheck look like? Well, this is what a ResCheck looks like. Basically, you enter, okay, hey, wall 1 is 360 square feet. You enter your cavity R value, your continuous R value, and you just go through and you enter all the walls and windows, what the R values are, how you're going to do it. A big way to game this system is do continuous R value versus cavity. Continuous, you get a whole lot better bang for your buck because you stop that thermal bridging through the studs. But you enter your home, click submit, and it'll give you a little green bar, let you know if that house passes or not. This particular house is 8.9% better than code. Or you can do the performance calculations. And again, the performance calculations, they'll model the house that you want to build. That's called the proposed design. And they'll compare that to a geometrically identical standard reference design that meets those minimum numbers that we looked at in that prescriptive table. It's all based off that prescriptive table and the mandatory measures being met. So those are basically the two linchpins of complying with the energy code. This is what an IC3 report looks like. This is just the outputs. Again, you'll put in the difference between IC3 and ResCheck is you've got heating, cooling, and water heater efficiencies. You've got duct efficiencies. So it takes all of that into consideration. Your mechanical ventilation rate, I see that screwed up as about as much as anything, and we'll spend a good 15 minutes here at the end on my little rant on mechanical ventilation and why it's broken in the code. But just a little more extensive. There's more inputs because it's dealing with energy costs, not just building thermal envelope equivalencies. When you submit for permit, or really at final as well, because you're supposed to do an as-built simulated performance calculation. So the compliance report at permit, it's going to show all of that analysis, all of those inputs, and then it'll also generate a compliance inspection checklist. And that's right out of section 405 in the energy code. You are doing inspection checklists. I'm assuming some of y'all do frame inspections as well, and you do other maybe bank inspections. But anyway, so if you're looking at the house, now granted, you're not going to be out there doing energy code inspections, but there would be a compliance inspection checklist on the job, or there at least should be. A lot of jurisdictions don't require the plans and the permit submittals on the job, but it sure is nice when they do have them. And then again, you'll submit a as-built verification when you're done, because when you're doing these performance calculations, two of the big things to input are your duct leakage and your blower door leakage. Well, you don't know what your duct leakage and your blower door leakage is going to be at permit, right? Of course you don't, because you haven't tested it, you haven't built it. So typically what builders will put in on their software is they'll just put in the maximum allowances. So in the 2015 energy code, it's 4 CFM leakage on the ducts, and it's 3 air changes an hour in climate zone 3, which is again the north, the Dallas and north, and it's 5 air changes an hour in climate zone 2, which is all of Central Texas and below. Needless to say, well, that's 40% tighter. So you have to be, once you start looking at those cooling climates, which Dallas is kind of a split, the homes have to be a whole lot tighter. That 5 air changes an hour, and basically what those of you that don't, well, I'll wait till I get to the blower door slide to talk a little bit more about that. So on the construction documents, when you submit all that, all of these details are specifically called out in code. So there's nothing that shouldn't be covered as far as when you're submitting this. I understand that we're doing real estate inspections at final, so I'm not going to beat that up too much. But let's look at these mandatory items, because you'll be able to notice that a lot of these, if they're missing, well, then they weren't done at final. So the first thing is the certificate. So the code requires, and actually in the 2021 code, I submitted a code change proposal that actually made it into the code, my very first ever code change proposal. So the 2021 IECC has an additional requirement on the certificate that it has to include the code edition that which it was permitted under and the compliance path that the builder chose, right? I mean, that's because if you're up there doing a final inspection and you see R6 duct and you know that R8 duct is required by prescriptive, by res check, by most compliance paths, especially in Central Texas, because most homes follow the res check total UA compliance path in Central Texas. Well, you'll know what code edition and what compliance path they follow. So it'll be a whole lot easier for you to differentiate if they have deficiencies in relation to energy code requirements. So that basically what the energy code says, and some building officials don't like it on the electrical panel, but I know most of the jurisdictions in Texas, most of the time you will find that energy code certificate in the electrical panel. If you don't find it there, it'll be up in the attic near the air handler or on the air handler. There's a couple of jurisdictions that they put it under the kitchen sink for some reason, but 9 times out of 10, you will find that certificate in the electric panel. And I'll show you more here in a second about what all that certificate, let's see, yeah. The next slide will show you what all the certificate has to have. On that certificate will be air leakage testing numbers. So you will have a number for your blower door test and a number for your duct blaster test. So those results have to be on the certificate. One of the mandatory items in the energy code starting In the 2009 Energy Code, ducts were required to be tested. And then in the 2012 and beyond Energy Code, the whole house also had to be tested. So again, if that house was built in 2017 or later, then it had to have a blower door and a duct blaster test by code. It needs that certificate in the panel by code. Another mandatory item, I mentioned this briefly earlier, those maximum U factor and solar heat gain coefficients apply. You cannot trade those off. You can't have crummier windows. We have found through our Texas Energy Code field study is that the window manufacturers are ahead of the game. They clearly had a prominent seat at the table on the ICC code hearings because the manufacturers, for the most part, were ahead of the game on that, and their U factor and solar heat gain coefficient requirements, 99 times out of 100, that won't be an issue. Every once in a while, you'll get a rogue window manufacturer that doesn't pay the money to have their window assemblies go through the NFRC, the National Fenestration Rating Council's 100 testing protocol, and they don't get those numbers. And so you'll have to. There was one in Oklahoma that was manufacturing windows there for a while. I think they have now gone away. And then every once in a while at the Home Depot, maybe on a homeowner edition or homeowner remodel or something like that, but typically your builder supply stores, the window manufacturers, that won't be a problem. But every once in a while at like a builder surplus or something, you might not meet those. Another mandatory item is controls. What does control mean? On a final inspection, on a real estate inspection, you're just looking for a programmable thermostat, and all homes have programmable thermostats. I think the only time they don't is, the little old couple buys the home and can't figure out how to program it, and they find some HVAC contractor somewhere that's got an old school dial one at the warehouse, and they haven't put that in. But programmable thermostat, that's what that mandatory item right there means on controls. This mandatory item on sealing and duct testing, that's just related to the flex duct or if you're down in the valley. Actually, it's kind of interesting for the real estate inspectors that don't ever do any work in the Brownsville, McAllen area. Whenever I go down there and do field training, 9 out of 10 new homes down there don't have any flex duct in them whatsoever. All the HVAC contractors down there are still doing it old school. It's all duct board down in the valley. Kind of interesting. You can go out to El Paso. I do field training in El Paso as well, and it's duct board plenums and runs, and then no longer than 10-foot flex jumper, or 10-foot flex. 10 foot is the maximum amount of you can use flex. But of course, from north of the valley all the way to the Red River and throughout Oklahoma, 9 out of 10 new homes, it's typically, frankly, it's typically an undersized plenum and just flex duct everywhere. So that's what we're looking at. That duct has to be sealed and tested. That's that mandatory item. This next mandatory item, building cavities, that just simply states that that building cavities can no longer be used as supply and return plenums. A lot of times, old school, you might have a fur down in a hallway, whatever, that was just lined with drywall that might serve as a return or a supply. Building cavities can no longer be used as return or supply plenums. I need to send off to ICC for an interpretation on, what happens when that you've got that upflow unit in a hallway, and well, that's a kind of a building cavity down below that serves as the return plenum. I would argue that building cavity probably needs to be lined with duct board. It needs to have some thermal resistance in the duct board, but on a return, is that really necessary? So I never really enforced that. I just wanted it sealed up and cleaned out. I'm sure y'all have all been in on final inspections where you look in that return cavity and there's just empty beer bottles or just dust and junk. And it blows me away how often builders leave those return cavities just full of junk. So that's just something, probably pull off that return grill and pull off that return filter and look in there. And those would be good pictures on that final real estate inspection report. Mechanical system piping insulation. The guys are doing this already. You know, basically your refrigerant lines have to be insulated. We're doing that. One interesting note on that is, and you can write this up for every single real estate inspection you do, out there at the condenser, that Armaflex, that piping insulation from the condenser to the wall, that Armaflex, the manufacturer of that piping insulation specifically says you have to protect it from UV and physical damage. The energy code also says that mechanical piping system insulation has to be protected from UV and physical damage, right? Because when you go do these changeout inspections, you know, as a building official, I'd go do a changeout inspection. Well, between the weed eater and the sun, that insulation on the refrigerant line at the condenser is always just eaten up and gone. And so the energy code and the manufacturer installation instructions both require not only that it be there, but that it be protected from UV and physical damage. And the energy code actually specifically says that tapes are not allowed. So that UV protected tape does not meet code. It needs to be some sort of UV and physical protection. Again, we mentioned the heated water and circular temperature maintenance systems. Not only will that hot water line need to be insulated, but that circ system has to be controlled. It just can't be on a pump running 24/7. Technically, it's not even supposed to be on a timer. It needs to be on a sensor. Me personally, as a code official, I was okay with it being on a timer. I mean, if you shower in the morning every morning and you just want to circ that thing for 30 minutes in the morning, that kind of makes sense. But technically, by code, that's not required. There are mechanical ventilation requirements. I'm going to save that for the end because, again, that's about a 10-minute rant here at the end. Equipment sizing and efficiency rating, that's also a mandatory item. The whole first hour of my second presentation at 10 is really going to harp on the equipment sizing. All I'll say about it now on this presentation is that it has to be sized per manual J. It has to be, equipment be selected by manual S. The ducts have to be designed by manual D. I've had over 600 HVAC contractors in classes the last year. The vast majority of them do not do that. And the problem is with this 2015 energy code, you know, we're sealing up our houses better because we have to, because we're blower door testing them, right? The energy code also requires this last one here, lighting equipment. Well, 75% of your lighting has to be high efficacy. In the 2018 energy code, it's 90%. And so we have LEDs instead of incandescents. You know, I joke that incandescents are heaters that emit light. And then we have a really tight house, and we have way better windows than we did 20 years ago, way better windows. And we have more insulation in the ceiling than we did. It's sealed up better. And then yet tons of HVAC contractors are still slapping that 5-ton unit in that 2,200 square foot house. Well, 20 years ago, that was probably sized right. You could probably use your 500 square foot per ton rule of thumb to size these things. You can't anymore. It's grossly oversized. And so there's short cycling, there's energy penalties, there's humidity and comfort issues. There's a handful of issues that come along with equipment sizing. But I can tell you, as a final inspection, if you're not seeing, at least, now rules of thumb and HVAC sizing never go in the same sentence. But unless you've got 20-foot ceilings and tons of windows for your average home, and just any average home whatsoever, I don't care if it's 4,000 square feet, I don't care if it's got a good amount of windows, as long as it's not a ton of west-facing windows. If you've got a 2,100 square foot house, I can almost guarantee you that thing should be, if it was sized correctly, I can guarantee you it would be a 3-ton or smaller. You can look at about a 700 square foot per ton rule of thumb. Now, granted, you can't call it out for certain on your inspection report, but what I would call out on my inspection report is HVAC equipment likely oversized, and maybe recommend that they get a copy of the load calculation from the builder. Certainly on new homes, that should be an easy ask, because I can tell you for certain we have a rampant problem with HVAC contractors oversizing equipment. We're not worried about systems serving multiple units or snow melt much in Texas. Pool and spa energy consumption, you can't have a constantly burning pilot light. You're supposed to have a insulated cover for your spa. I don't really think or if your pool can be heated over 90 degrees. Those probably aren't items that I would recommend calling out, but just wanted to make you aware that those are mandatory requirements. And again, on a final inspection, you need to be seeing on a home built in 2017 or later, you need to be looking at 75% or higher. Basically, they call it high efficacy lighting. Basically, you're looking for LEDs or CFLs, but that isn't really a problem anymore. Back when I was building official in Granbury 5 years ago, or it was about 7 years ago, and we adopted the 2012 Energy Code, that was the builder's biggest complaint, was that the increased cost of LEDs. That shouldn't be an issue anymore. So this first mandatory item that's required, the certificate, it doesn't necessarily have to be this exact form, but it does have to have all of these inputs. It has to have the R value of the ceiling roof. Now, this is the predominant R value. If you have HVAC walkway, maybe they didn't fur it up and they've got, 400 square foot of R19 for the HVAC walkway. Maybe they've got 300 square foot of R19 on a vault in the master, or whatever it may be, but the whole rest of the house is R38. Well, this will be the predominant value. Now technically your energy code submittals at permit, that's where they would capture the reduced insulation on the R value for the HVAC walkway and the vault ceilings and all that. But for the certificate in the panel, it's kind of unfortunate that it doesn't break it down a little more. But hey, at least with the 2021, we'll have energy code and compliance path used. Wall R value, we don't have basements or crawl space much. We don't do much mass, but you'd be looking at floor R value for those bonus rooms over unconditioned space. And what is our R value of our ducts in the attic? This is where we're going to have our blower door result and our duct testing result, our window information here, and then heating, cooling, and water heater efficiencies here. So that needs to be on the panel. And if those don't meet those numbers that we showed in that earlier table, then, well, they would, or they wouldn't have put it in the panel. So really what you would call out is no energy efficiency certificate. So that's what I would call out at the final, is it's missing its energy and efficiency certificate, because that is a mandatory item. So just to get an idea of how this has increased over time, and this is another reason that 500 square foot per ton worked a whole lot better 20 years ago than it does now. It's because 20 years ago, if you just kind of slopped some mastic on and sealed it, you're going to be about 12 to 20 CFM leakage just on average. Well, when the 09 came in, they said, okay, if you're going to test it at final, you're allowed 12 CFM leakage. Well, now with the 2015 energy code, you're only allowed 4 CFM leakage. So it's gotten a whole lot tighter. We're leaking a whole lot less of our conditioned air into the attic now. So we're getting better air delivery. We've got better windows. We've got LEDs. We've all of these efficiency improvements, and yet we're still slapping in that 500 square foot per ton unit. This is another reason we really got to start calling that out on these final real estate inspections, to just get it through these guys' heads. And I understand it if these HVAC contractors, they don't have somebody in the office, and man, new home construction, that is a dog eat dog business. And yeah, I am a tree hugging hippie working for an energy efficiency nonprofit, but I also live in the real world. And I know you can't build a doghouse to code, so you darn sure can't build a house to code. And ultimately, we're going to need some rules of thumb. I mean, if I'm an HVAC contractor and I learned it from my dad, who learned it from his dad, and we never did load calculations, and we've always just done rules of thumb, and the municipality doesn't require the JS&D, and Okay, all that's fair enough. I live in reality. All I'm asking is you bump your rule of thumb up from 500 square foot a ton to 800 square foot per ton. And I can promise you, you're going to be able to meet those code requirements. Now, I mean, the meet comfort of the occupants. Now, granted, I thoroughly recommend JS&D 100% by the book. I encourage municipal inspectors to require the appropriate submittals to verify that. But it's a long road, and I'm just not making incremental change on that right now, but that's part of how I spend my time, and we are making change. And I know I do some, I coordinate with TDLR some and do some trainings with their enforcement, Bill Weatherly, their chief of compliance and enforcement. And TDLR is getting more and more, placing more and more emphasis on these load calculations as well. So we're slowly but surely, they're coming kicking and screaming, but we're going to bring this HVAC industry up one way or the other. So those of you that haven't seen a blower door, don't know what a blower door looks like, this is what a blower door is. Basically, you've got a metal frame with a vinyl cover, a fan, and a little computer that tells you how much it's leaking. And basically what you do is you close all the doors and vents, and you close up the house except for one door. You're not supposed to seal off like dryer vent and stuff like that. But what you'll do is you put this in, front door, back door, it really doesn't matter. Just put this in an exterior door, you seal it into the doorway, and typically most raiders will depressurize the house. That helps the exhaust vent and the bathroom exhaust and the kitchen exhaust and the dryer exhaust. All of those dampers should close and seal. So you depressurize the house to 50 pascals. A pascal is a unit of pressure. Roughly, it's supposed to be simulating a roughly 20-mile-an-hour wind. And basically, that house can be no leakier than the entire air volume in the house being exchanged for five times an hour in climate zone 1 and 2, and then 3 air changes an hour for the rest of the country. So Dallas and North, 40% tighter than Central Texas and South. So basically you could walk a frame inspection, and as long as you're not seeing daylight through the sheathing, you've got good, a good poly seal everywhere, you're not seeing daylight, and you're going to pass that 5 air changes an hour all day. You get up into the DFW in the climate zone 3 area, and you're having to do some top plate and bottom plate gasketing. Now granted, that toe plate, the base plate is required to be sealed to the slab anyway. So if you are doing framing inspections as well, you'll want to check that that's sealed to the slab. That would be something you could write up. But basically, you're not going to pass your blower door at 3 air changes an hour if you don't go above and beyond for some of these air sealing areas. Here's some just areas to look at for air sealing if you're doing framing inspection, or if you're doing on a final, any of those knee walls, any penetrations from non-conditioned to conditioned space, any of those penetrations will need to be sealed. It's required by code. There's an air barrier and insulation installation table in the energy code. I'll show some little snippets from it in a second, but basically anything that penetrates the building thermal envelope, anything that penetrates conditioned to non-conditioned space shall be sealed. The good old shall word in the code. There's no gray area. You have to seal it. Obviously, all new construction now, we're going to have IC rated. They call it ICAT cans, insulation contact airtight cans. And if you're like me and you have to wear these readers to do anything, good luck. And they make the print so microscopic on these cans, but you should be able to see somewhere on those cans ICAT, insulation contact airtight. Not really too much of an issue anymore. Most of the supply houses have that down. Code requires it doesn't necessarily require a ladder frame. This is an example of a ladder frame. My builders in Granbury would just order for all the T's, maybe there's 14 T's on the job. Well, they could reduce their 2x4s by 14 or 20 and just increase, they'd have 14 2x6 studs delivered. And you flip a 2x6 on edge here behind this stud, and you've got nice drywall nailers on each side. And what code, it doesn't require a ladder frame, but what code says, the energy code says, is that T's shall have room for insulated material not having less than R3 thermal resistance per inch. That's a long way of saying we have to get some fiberglass or foam behind these T's. And if you think about it, it makes a huge difference. It drives me crazy when I'm out doing field training. And I'm telling you, man, it's Georgetown, Bryan College Station, I mean, some bigger, Temple, some bigger, faster growing cities still aren't requiring this. And so people are buying brand new homes that are supposed to be being built to the 2015 energy code. And you look at a 2,000 square foot house and you calculate it up, you're going to have 14, 16, 17 T's at exterior walls, right? Well, the old school way of framing it, what do we have? We have a stud here. Basically, you build the studs, right? You build the studs with blocks, and ultimately you have a stud on this side for drywall nailer, stud on this side for drywall nailer, blocks in between for nailing this stud too. And if you add up those 14, 16 T's, you have a 4-foot section of wall, right? That a third of that 4 foot has R0 because it's just the space in between the blocks. And then 2/3 of that wall has R3.5, the thermal resistance of a stud. Well, who wants a 4-foot section of wall with a combination of R3.5 and R0 when with no more lumber, no more skill, no more effort? It's actually cheaper to do it this way because you could use leftover lumber for the ladder frame. And instead, you've got a 4-foot section of wall. Yeah, if your fiberglass is compressed, we'd call it an average, say maybe an R11. So you go from R3.5 and R0 to R11 in a 4-foot section of wall. It's going to make a significant difference on your utility bill. A huge source for leaking, this rim joist. If this is on a 2-story, imagine this being a rim joist. Energy code requires that all of this rim area shall be sealed. So you can't, it takes a sealant, not just nails. Technically, window energy code requires headers shall be insulated. I mean, I tell builders all the time, I mean, OSB and 1/2-inch foam is the same price. Just subtract 2 or 3 sheets of OSB and have 2 or 3 sheets of 1/2-inch foam delivered. And think about, you add up all the headers on a house, and for, you know, you can go 60 square feet a header easy, and you're going to double the thermal resistance in those headers by using 1/2-inch foam. Again, all these penetrations, if you're doing real estate inspections, I would recommend pulling off one HVAC diffuser or one exhaust fan trim, or one can light trim. Now, granted, you'll have to look up in the attic as well, because sometimes they'll seal it up in the attic. But all of these penetrations through the lid, energy code specifically requires, it says they shall be sealed. All these penetrations. Now, we seal these for fire as well, but all of these penetrations shall be sealed on the energy code. Air barriers on knee walls. This is a real big pet peeve of mine. It straight out calls it out in the energy code. And oh my goodness, if you're doing a final inspection built in 2017 or later, you need to be calling this out as a deficiency in your inspection report. Energy code straight out says knee walls shall have a rigid. So you have to have an air barrier on the unconditioned side of these knee walls. You know, we have that 135-degree attic air moving through the attic, right? And fiberglass doesn't really stop airflow, certainly doesn't stop it at only 3.5 inches of thickness. Blown fiberglass, after about 7, 8, 9 inches, it does significantly diminish that airflow, and you don't have a whole lot. That's one reason why we're blowing 12 inches. It's still doesn't qualify as an air barrier even at 12 inches. I have people ask, well, why don't I have to deck the attic then? Well, we've got 12 inches of blown on the attic deck where we've only got 3.5 inches of fiberglass here. And so having that rigid air barrier on the knee wall, and you can get a thermal gun now for about $80 on Amazon. They used to be 5,000, right? And just one second. Sorry about that. The rigid air barrier is required on these attic knee walls, and a couple of reasons why. And really, it even prior to the energy code, it was required because it was required by the manufacturer's installation instructions. That's where you could have dinged them for it. But now it is black and white, that knee walls shall have an air barrier. So if anytime you're up in an attic and you see in a vertical wall assembly a bat, write that up, and just air barriers required on knee walls, straight out of the code. And I'll show you where it says it in the table.
Hey,
now,
Jason.
Yeah, go ahead.
Yeah, sorry, we have a few questions. Can we take a couple of minutes?
Yeah, we have to.
Okay, so there's a question. How exactly well or should the T-wall framing be sealed?
Oh, wow. That is perfect timing, because this is exactly what this slide shows. So shall be sealed, in my mind, means sealant. And even more so, a sealant that allows for the differential expansion of differing building materials. In reality, if it's a knee wall like this, as a code official or as an inspector, if I have like 4 inches on center fastening pattern and it's real tight and I'm not seeing gaps, I would be okay calling that sealed. But what you'll find a lot of time on these T-ply walls is they've got a nail every 2 feet and you've got 1/2 inch gaps in that T-ply. That ain't sealed. This picture is from the Building America Solution Center, and they specifically, you see the poly on this knee wall, right? And so shall be sealed to me means a sealant. But if I'm an inspector and I've got a real tight fastener pattern and it looks like air can't get through there super easily, I probably wouldn't write it up. Oh, let me go back one. And just to, if you're ever working with builders, or maybe you're doing a retrofit. I know this fall, now that actually I'm in the middle of building a cantina bar in my backyard right now. Priorities, right? I got to get my cantina bar built so I can sit at it and watch football. But after I do that, I'm going to go back and all my knee walls in my attic, I'm going to get 1 inch foam board. So I've got an R5 thermal resistance, right? Instead of R3.5 through the stud. But when I cut it, what am I going to do? I'm going to cut it 1 foot taller, right? So it acts as an insulation dam for my blown, so I can get a full R38 over the header. So what perfect timing for that question. Let's go ahead and do the other ones.
Perfect. Would you recommend the 700 in climate 2, 3, and 4?
Yes. 700. Now, granted, I would but once again, rules of thumb and HVAC never belong in the same sentence. But I can tell you for a fact, unless it's just a huge 20-foot wall covered in windows, like I said, but just 99 out of 100 homes, any of your normal Lennar, KB, DR, any of those production builders' homes, 99% of custom homes, if you're not seeing at least 700 square foot per ton. Now, in all of climate zone 2 and 3, throughout Texas, if you're not seeing at least 700 square foot per ton, and I know people that design and install HVAC all day, and they'll tell you they've never done one that's less than 800 square foot per ton. But I want to give them the benefit of the doubt, and I know for a fact, if you're not seeing at least 700 square foot per ton, that air conditioner is oversized. Now, granted, you can't call that out as fact in your inspection report, of course, because you don't have a copy of the load calculations. You don't have you don't have all of that information. But what you do need to call out is HVAC likely oversized. Recommend get a copy of load calculations or something like that. That I would call that out every single time if they're under 700 square foot per ton. Okay, the next one.
Okay, is insulation required on hot water piping if it does not have a circulation pump?
Yes and no. So it's required in some areas. It's required in the slab. It's required. So that's funny. I just went through all this for Granbury just this morning. I was finishing up. So in climate zone 2, most likely, because in climate zone 2, most builders use res check. Res check is total UA prescriptive, and hot water piping insulation is required 3/4 inches is bigger, required if it's buried, required if it's in the slab, only if you're following the prescriptive path. So in climate zone 2, and yeah, this is just such a hard thing to write up because, well, what compliance path are they following? You don't know because you don't have the submittals. But it's a pretty good rule of thumb. Those folks in Central Texas and lower, most of the time, most of those builders use a res check, which is a prescriptive path, which would require half-inch pipe longer than 20, depending on what code they're on. They keep changing that up. So unfortunately, that's a yes and no. And the good old answer, it depends. But what I would say is that always on circulation system piping, always has to be insulated. 9 times out of 10 in climate zone 2, it would need to be insulated. And then in climate zone 3, they probably did the performance calculations and maybe they didn't. So yes and no, but always on circulation systems. And feel free to shoot me an email because I've already written all this up actually for the city of Granbury this morning and highlighted the code areas and what all that are. If you really want to get into the weeds on it, the weeds are required because it depends. All right, next one.
Okay, we'll do one more. If an attic with spray foam insulation is considered a conditioned space, can lighting and vents be sealed at the ceiling?
They can be, but it wouldn't be necessary. And in fact, you probably want a little more leakage through your ceiling just to help the destratification of the moisture up at the ridge, allowing it to communicate a little better. I probably wouldn't go through the trouble of sealing that some builders, they'll run a little return or a little supply into the attic. But no, it wouldn't. Now, granted, the code still says it shall be sealed. So the code doesn't differentiate, but frankly, in my opinion, and most building scientists would tell you it's really not important at that point. But codes does specifically say shall be sealed. Now those can light trims, they all have gaskets, so that qualifies as a seal. But yeah, technically your HVAC boots and your exhaust fans and your baths, those should still be sealed even in a foam house. So you want me to just keep going for now then?
Yes, we'll just keep going.
Okay, great. If you're looking at, and I sent off to ICC for an interpretation on this the other day, and basically for baffles, what code says is these shall be installed adjacent to soffit vents. So what that tells me is that if I have a continuously ventilated soffit, right? If I've got on the outside of this, I've got a continuous vent, holes poked everywhere. Well, I need a baffle in every rafter cavity. In addition, now you wouldn't need it in this. But if I've got a vent cut every 4 feet, well, I would just need a baffle here and here. And a rater was arguing with me that, oh no, you got to have them in every cavity. So I sent off to ICC for an interpretation. What ICC says on this is that it's a performance requirement. And basically, now, you have to have, we all know, and man, y'all can write this up all day long too, I'm sure, underventilated attics, right? So attic ventilation, we have to have what, 1 square foot of opening for every 300 square feet of attic, right? Well, don't allow them to use those 12-inch, I'm wanting to say stagnant, just the louvered vents, the non-mechanical 12-inch vents. That does not have 1 square foot of net free area opening. Now, most of the time it's like 0.6. Depending on manufacturer, it's about a half a foot. So if you go up into the attic and say it's a 3,000 square foot house, so we need 10 square feet, right? So we need 1 square foot for every 300. So we would need 10 square feet of attic ventilation, half of it at the top, half of it at the bottom. Well, if we've got continuous soffit vent, that covers our 5 square foot at the bottom. Well, if you've got 5 of those static 1 foot vents, it's grossly underventilated because you needed 9 or 10. But anyway, back to the performance requirement. Basically what ICC says is that these bats is a good way to make it perform. But there has to be a method installed to keep, so on really windy days, wind comes through these soffit vents and out through the top and vice versa. These baffles shall be installed such that the insulation will perform. So in other words, this whole rafter cavity needed to be filled with one of those like cardboard baffle. There has to be some mechanism in place to keep the blown insulation from blowing down into the soffit and from blowing back off the top plate. So you could call out the baffles. Baffles will not perform properly, or just shoot me an email if you want to start writing that up. I'd recommend it, and I can word it the right way for you based on code. But it has to be installed such that it performs. Right, and you see this all the time. Just needless to say, on this vault area, these areas are just going to fill up with hot air, right? So if you see any vaulted areas that, if you're doing now granted, most of y'all are doing final inspections, you're not going to really see this. But when you're doing that final inspection in the attic, if they're a lot of times back in the corner, maybe on a master or something, you've only got 2 or 3 inches between this decorative ceiling and the roof deck. Well, blown's not going to reach and fill this area. So peek back over in there and make sure that they filled this with bats. If you're doing framing inspections, I always like to walk the job and think about where's blown not going to reach. Well, clearly blown's not going to fill this little corner, right? So any of these areas would need to be, I do insulation trainings for just insulation installers for NAMA, North American Insulation Manufacturers Association. And I always tell those guys, think about the guys coming back and blowing the ceiling. Where's blown not going to reach? A lot of times, if you're doing a final inspection, just little decorative ceilings above tubs, or decorative ceilings can be a real culprit in these areas that aren't getting filled with blown insulation. So you might want to give a little extra attention to some of those decorative ceiling areas. If you are doing framing inspections, this is no good, right? It has to be split or cut to fit around wiring. And this is just straight mandatory items out of the energy code. Not only is required in the energy code, it's required by the manufacturer's installation instructions. So this is straight out of the air barrier and insulation table. A continuous air barrier shall be installed in the building envelope. So that kind of covers those knee walls, but it also then it goes further and calls out knee walls here specifically. So any drop ceilings shall be aligned with the air barrier. So it can't just be fiberglass there, right? We have to have an air barrier, some sort of air impermeable material. Here, knee wall doors. So basically there's a whole big table out of the energy code, and it breaks down each component, general requirements, ceiling, attic, walls, and it talks about how the air barrier has to be installed, and the installation details. And I tell builders all the time, if you look at nothing else in the energy code, this one page, this table 402.1.1, you're 90% of the way there if you just follow all these details. Here on the walls, knee walls shall be sealed. Now you don't get this very often, but just FYI, the junction of the top plate and the top of exterior walls technically shall be sealed. You don't get that very often. Again, I would probably be okay with a real tight fastener pattern along the top plate, but shall be sealed is more than just a tight fastener pattern by the verbiage of the code. So you know that. And here we talked about, this is cavities within corners and headers of frame walls, within corners and headers. And so all cavities in the frame walls basically need to have some sort of foam or fiberglass. So again, this, and we see this on a framing inspection, right? The space between windows and doors, they shoot that with that low expansion foam, right? Yeah, make sure they're not shooting it with the normal high expansion foam, or they're going to have problems closing their windows. Just FYI, this is a neat little video, just shows you how. So imagine this is code requirement. This isn't above code. Imagine a little bonus room above a garage. So we're looking at this bonus room, right? So we've got garage under here, and then we've got unconditioned attic space here. Technically, this is what code would require. Okay, we've got to fur these out so we can get an R30 instead of an R38. certainly prescriptively. And if they're in, or they could possibly trade it off, but we'd need to see the calculations. So all of this unconditioned air, this technically needs to be blocked and sealed, shall be sealed. Those joist cavities shall be sealed. You can't just have that because, right, air permeable fiberglass insulation doesn't qualify. You've got to have this air barrier here. So that, and then we have to have a rigid air barrier on the attic side, right? We've got to have, technically, OSB manufacturers, there's got to be 1 inch airspace clearance. So really you would need now granted, you don't get this all the time, but by code and by manufacturer's installation instructions, you would really need a ridge vent here, soffit vents here, and a 1 inch gap between your roof. Now you're not always going to get that, but it would be certainly something you could write up. This is sealing of this is just an example of sealing the exterior top plate. So all on the exterior wall, all along the exterior. Now, you don't get it much in climate zone 2 just because you can still pass your blower door test without doing this. Most builders in climate zone 3 are doing this just because running a little seal here, that'll drop their blower door by about 1 air change an hour. I've had on good authority, actually from a rater that taught a class yesterday. I believe in he'll probably let me know if I'm wrong, but I think Steven Reinhardt said that he's seen about an air change an hour drop just in like a 4 inch on center fastener pattern across the top of the drywall. So again, probably not quite technically sealing, but we kind of live in reality, and let's don't let perfection be the enemy of good. Just those of you that don't know what advanced framing corners and headers are, corners are, we don't use drywall clips much, but you could do a 3-stud corner. They call it a California corner as well, or a 3-stud corner. We don't like to emulate California very often in Texas, so I typically call it a 3-stud corner. That's what that looks like. And again, well, we already talked about the ladder frame on the T. And the whole point is getting that material behind it that has that thermal resistance of not less than R3 an inch. So in other words, fiberglass or foam. So again, it would have taken 2 more studs to build the traditional T, and then we'd have a 4 to 6 foot section of wall with almost no insulation in it. Well, we can use 3 pieces of scrap, have drywall nailers, and then when we can get the fiberglass behind, good luck getting a fiberglass guy to cut that out, but technically you really should. But not going to let perfection be the enemy of good. We're just going to make sure that it's filled. So again, you're looking for at least 75% of lights. In the 2009, it was only 50%. Now it's 75. Where am I at? 926. So we'll have plenty of time for that mechanical guideline. New versus old. Another big reason why LEDs are great and why we're having less heat gain. A 60 watt incandescent kicks off 54 watts of heat. That's why I joke that they're heaters that emit light, whereas a 60 watt equivalent LED kicks off 1.4 watts of heat. Man, if you're not as busy now with COVID or whatever, or you're looking to do some home efficiency retrofits, if you've got a house built in the 90s or before, you can get those LED can light retrofits. And so if you've got non-IC cans, man, those LED can lights, they've got a gasket on, you can slide them right up, and for like $9 a can, you can transform your non-IC can into, these don't kick off enough heat to worry about it, but that's a great quick payback retrofit that you can do for your own home. A great idea. I'm not going to beat this up too much. I just want to let you know that it is in the code. JS&D is required by code. This has been in the mechanical code and in the mechanical chapter of the IRC for 30 years. Okay, so this is broken in code, but I just want to call it out to you because if you are doing a final inspection, you're probably going to want to, on newer homes, you're going to want to look for a whole house mechanical ventilation. So basically what the code says is once you get to 5 air changes an hour or tighter, then whole house mechanical ventilation is required. Well, from the 2012 Energy Code and on, 5 air changes an hour or tighter has been required. In the 09 Energy Code, it was 7 air changes an hour. So you could meet the Energy Code and come in at over 5 but less than 7, and whole house mechanical ventilation wasn't required. And it's kind of, counterintuitive. And, you hear builders, well, so I'm going to spend all this extra money and effort sealing up my house real tight to plug something in to bring in outdoor air. That doesn't make any sense. Well, it kind of does, because if you've got a really leaky house, well, do you want dust coming in from where the can lights and exhaust fans weren't sealed? That good old fiberglass dust coming in from the attic, where you didn't seal the garage to house connection wall. You didn't get that toe plate and top plate sealed. You didn't seal those penetrations. Well, do you want, in the garage where we keep our gasoline and fertilizer and chemicals and insecticides, you want all that leaking into the house? No. The idea is you seal your house up really tight, and then you know how much ventilation you're bringing it in, and you know where you're bringing it in from. To me, if I'm building my own house, it's an absolute no-brainer. I'm using a Q-Fresh fan. I'm partial to Q-Fresh because I know the owner of the company, and he's a good dude, and he's tested his against the competition, and I know his works well. But I want a supply-only fan, so I've got slight positive pressure on my house at all times, but I'm not ventilating it to these rates, and here's why I'm not ventilating it to these rates. So ASHRAE 62.2 is the committee that comes up with these numbers, and in my opinion, they are trying to stay away from, Jeff Adams and I were joking about this the other day, they're just trying to stay away from lawyers. And so they're doing it on a worst case scenario. So just imagine this situation. Now these numbers come out of that ASHRAE 62.2 calculation, but this table's out of the IRC. They just basically dumbed it down for the municipal inspectors, like, hey, rather than doing the calculation, here's about what the numbers come out to. If you did the exact calculation, it's going to be within a few CFM of this. But here's the problem. You've got one of these production builders, right? And they're just building carbon copies of homes everywhere, right? Well, say my neighbor and I, we both have a 4-bedroom, so we'd fall in this column, 3,200 square foot house, so we'd both fall in this column. So we'd both be right here, right? My neighbor and I. Well, me, with 2 kids that go in and out of the house all day, because I make them, otherwise they'd just be staring at a screen, right? But no pets. We don't cook. We eat out. I'm doing like 3 loads of laundry a day. Every time you run the dryer, it's exhausting air, right? I love to open the windows in the spring and in the fall. Well, my wife and I, in our 4-bedroom, 3,200 square foot home, we need 90 CFM of outdoor air being brought into our house 24/7. Okay. Little old couple next door in a carbon copy, 4-bedroom, 3,200 square foot home, 9 cats, 3 dogs, never open a window, never go in and out of the house, fry 3 meals a day, don't even turn on the vent hood when they do. They also need 90 CFM of continuous outdoor fresh air brought into the house. Does that make any sense to anyone? This is when it's so beneficial to have people in the room so you can see facial expressions, because the facial expressions are always, well, that's dumb, that's broke, and it is. It's just flat out broken code. But how do you incorporate into code human behavior? It's a really tough thing. And so what you want to check as an inspector is that it's installed such that it can meet code. And basically what you're looking for, most builders in Texas, they'll use that. You'll see it. It's a little it's a damper. They'll run a little 6-inch duct to the soffit to a Honeywell damper, and there'll be a little Honeywell controller on the air handler. And basically what that controller does, and there's 3 dials on it. There's number of bedrooms, square footage, CFM, all those will be turned all the way down. And I mean, it won't be set up right, but at least it could have met code. Or you can use an exhaust only strategy. So here's the 3-way code lets you do it: exhaust only, supply only, or balanced. Balanced is the Cadillac. That's the ERV, HRV. But frankly, between maintenance and installation costs, I wouldn't do this. And I'm a tree hugging hippie, right? If I'm building my own house, what I would do, I would use that 6-inch vent, sure, run it to the soffit, but I would install I think it burns 23 watts, right? A little Q-Fresh supply only fan, so it's filtered, and it's drawing in a continuous stream of outdoor air, filtering it, delivering it to my return plenum, which is then being distributed throughout my supply. So I've got a little trickle of outdoor air being input into my house at all times. But the key is with like a Q-Fresh, or like I said, Panasonic and Broan makes them too, it's smart ventilation. So in Houston, when it's 90% humidity and 98 degrees, that controller on that fan shuts off. So when it's too hot, too wet, too cold, too dry, it's not bringing in outdoor air, right? We don't want to be bringing in outdoor air when it's 14 degrees outside. We don't want to be bringing in outdoor air when it's 90% humidity and 100 degrees outside. That's just dumb. But the cheapest way to do it is exhaust only. And what code says, if you do it exhaust only, well, I don't have that table. It's 2.8 CFM per watt. So basically, the code says you can do exhaust only. You'll need to meet this, which, you know, your standard bathroom exhaust fan will be 75 CFM. You upgrade a little bit, and it's going to be 100. So that's going to cover your 5-bedroom, 4,500 square foot house. But what the energy code says is that whole house mechanical ventilation fan has to meet an efficacy minimum. So basically it has to meet 2.8 CFM per watt, which all basically you need to look for is it's going to have an Energy Star or 62.2 compliant sticker on it. If it meets Energy Star or 62.2 compliance, then it's going to meet the energy code requirements. But now granted, you could just change out any exhaust fan in the house for an Energy Star 62.2 compliant exhaust fan, and also energy code requires it be controlled. Well, a light switch is a control, so you could just swap any of those cheap builder grade $40 exhaust fans out for a $90 Energy Star exhaust fan, and voila, you meet the whole house mechanical ventilation requirements. Now, granted, the home builder's not going to tell the homeowner that that's their whole house mechanical ventilation system. So the homeowner's just going to turn it off, and they're never going to know. And if they've got animals or if they aren't very clean, they're going to have some indoor air quality problems. My wife and I in and out of the house all day, kids in and out, and, you know, take a shower every day. And so it's broken in code. I hope it gets fixed. A friend of mine is now on the 62.2 committee at ASHRAE. And he realizes it's broke, so I hope there's better stuff coming out of there. But as a final inspection, if you're looking at that Honeywell controller, if you see one of those Honeywell controllers and the ducts run over to the soffit, well, that's a supply-only strategy. But what energy code says, if it's an old school 14 SEER single speed air handler, you cannot do it. Because what energy code realizes is that for a whole house mechanical ventilation system, the fan's got to be efficient. So it's got to be a 16 SEER or better. It has to have an ECM motor. When it's mechanically ventilating the house, it needs to be running on low speed. So if you're just looking at that builder grade Goodman unit out there and you see that Honeywell controller, I would write that up for a non-ECM motor, non-electrically commutated motor. Code requires it be an ECM motor if they're using that. This is kind of interesting, and this is for exhaust duct, and if you go in there and look, and you could just write this up all day long. You look at the installation instructions on the exhaust fans, and they all are speccing it on 4-inch hard duct. And what do we always get? 3-inch flex, right? That it's just sagged everywhere. When you look at the maximum length of flex duct, right? I mean, it depends on how many CFM. That 80 CFM, you can run it 4 feet on a 4-inch. And so you could write that up all day long. I probably wouldn't hassle with it, but just if you're needing something, that's straight out of the mechanical code or the mechanical chapter of the IRC. We're running a little short on time. I'm not going to go through ERI basics. We have less than a couple of thousand homes that go through ERI. Again, this is just equivalent to HER score. And since the title of the class was that, I want to make sure and get over that mechanical code document before we finish. Just so you know, the numbers for the ERI have been amended in state law. They've been amended higher than is required. Basically, ERI is a 0 ERI is a net zero home, and 100 ERI or HER score is a prescriptive home built to the 2006. So a 50 ERI would be 50% more efficient than that 2006 home. It's basically how that works. So again, all of these additional resources, those will be sent in the in that basic mechanical code guideline. So you'll get a copy of all this. And so let's hit that, what this was supposed to be about real quick. Let's go over this. And it's just not very visually appealing. And I could have made slides, but it would have still just been, you know, just words. And so I want to kind of look at some of the highlights. So basically what I did with this document, and it's handy, it's front and back. So it's 1, 2, 3 pages. So a page and a half front and back is the way it works. And the first page, all these bullet points, is what I did is I went through the mechanical chapter of the IRC, and everything that was significant got a bullet point. So here's one that you'd be calling out for on a final real estate inspection, right? Passageways to HVAC equipment shall be large enough to remove the equipment, but in no case should it be less than 22 inches wide and 30 inches high. You see that all the time, right? You see this all the time too. If those, what do they do for the decking for the service deck, right? They throw it on top of joist 16 inches on center, and they use that 7/16 OSB, right? No. I would write that up. You need to double the OSB or use 5/8, because if those joists are 16 inches on center, code requires 5/8 minimum OS or 5/8 minimum nominal lumber or OSB for the service deck to the HVAC equipment. If it's 24 inches on center, it's got to be 3/4. The walkways to the service equipment, at least 2 foot wide. Remember, in front of the equipment, we've got to have that service deck at least 30 by 30 inches, right? Typically, unless they're trading it off and listing it in the specifications, I would write up, you know, service deck. That's a tough write-up because they could have potentially traded it off, but really they need to elevate the service deck so you can get the full R38. But that's kind of one of those gray area things like the hot water piping insulation. That's going to be tough to write up. But if you are interested in writing that up, let me know, and I can give you some guidance on how the best way to do it. We all know rigid gas lines have to exit the furnace, right? The walkway to the equipment has to be illuminated, right? The switch at the entry, it specifically says the switch has to be at the entry. This is only in the Uniform Mechanical Code. It's not in the International Mechanical Code. So we're not going to worry about that. The gas shutoff valve is supposed to be in the same room, no further than 8 feet from the appliance, right? Gas connectors can't be longer than 6 feet. Venting, gosh, how often do you see those vent pipes just kind of haphazardly installed, right? No, we need sheet metal, at least 1 inch clearance. Primary condensate drains shall be insulated when in unconditioned space. I can't tell you how often they don't insulate the primary condensate. And you get up there, you know, in August, maybe that house changes homeowners or whatever, and it's 98 degrees in the house. You turn on that air conditioner and it runs for 2 days straight. That condensate is going to be dripping all on the drywall. It has to be sloped, obviously. You know, we're 20 minutes till. Rather than reading all this, there's not, again, it's a really handy guide just because, oh, this man, I've written a ton of red tags on this. This would be a good one on a final real estate inspection. Those condensers by the manufacturer's installation instructions must be level, and it will wear those fan motors out if they're, how often they set that pad and they've kind of halfway graded it, and then you get a big rain. Man, I've written a ton of red tags for condenser pads not being level. It drives me crazy. Obviously on the disconnects, you want to match the breaker disconnect requirement with what's in the panel, right? You catch that all the time. At the condenser, it'll have a maximum breaker size. So that's a good one to catch. Yeah, those are probably the main ones for HVAC. This is a really good, just some myths about duct design and sizes, and we'll go through into this in this next presentation starting at 10. We'll go through this quite a bit more. I've got a couple of videos. I've got some other things to show. But really what you want is you want a return in every bedroom. You don't necessarily have to have it, but it works a whole lot better. And I'll show you in the next presentation. And I'll go ahead and just kind of tease it here. If you got a master bedroom that doesn't have its own return, I can guarantee you it's got a supply or two in the bedroom itself. It's got a supply or two in the bathroom, and it's got a supply or two most likely in the closet as well. You'd need about a 7-inch door undercut to get based on the CFM being delivered to this room, to that room. And I'll show you a chart in the next presentation for those of you that are coming back for that. Or if you're interested, let me know and I'll send it to you straight out of Manual D. Returns are grossly undersized. I mean, Bryan College, just don't get me started in some of these cities where it's just undersized, but it gives you some just general guidance on that. And then I mentioned, it talks about some of the pressure, friction rate and pressure drop and some of those things. And then I really like this section here. Additional, this is all HVAC related resources. So that's super handy to have. And we've got 15 minutes left, so I will stop and do questions. Oh, the Corona Due edition's coming next. So that's starting at 10. So, oh boy, a bunch of questions.
So I took down a few that we can answer before we let everyone go.
Okay.
So there's one, do you see a trend for Texas cities requiring an energy audit for new builds?
Well, no, I don't, but it kind of, it should be being done by default by energy code requirements. Because really, the energy code requires a building thermal envelope and insulation inspection. It requires the final inspection, and it requires blower door and duct blaster testing. So that is somewhat of an energy audit. Now, granted, you don't go back and look at the energy bills and look at any sort of energy use intensity per square foot or anything like that. So that part wouldn't be required, but you are kind of getting a de facto energy, certainly at least an assessment, just by energy code.
Okay. And then the next one, in high humidity areas, can a home be too tight? Worries exist with potential storm exposure and damage.
No, a home can never be too tight. A home can be underventilated. If you have, especially if you've got a really small home that's fully foam encapsulated, and a lot of times those will come in 1.5 to 2 air changes an hour. If the builder uses the exhaust only ventilation in that, doesn't tell the homeowner that that's their ventilation system, so it's never turned on, that house can be too tight, but it's not necessarily too tight. It's really just underventilated. You cannot, how many, raise your hand if you want holes in your house. How many holes do you want in your house? You don't want any. You want the right amount of ventilation. And again, ventilation, the linchpin of ventilation is occupant behavior. And so there is just not a really good answer for that. As far as the ventilation requirements, it's going to be based on house to house and what you do in the house and the occupants. But what I can tell you with 100% certainty, you cannot get a house too tight, but you can underventilate it.
Perfect. And then what's the purpose of fresh air intake for the HVAC system?
Well, that just serves as your whole house mechanical ventilation requirement in code. I personally hate the Honeywell controller system, because think about, so basically the purpose is supplying outdoor air to the house, because the energy code has required the house be 5 air changes an hour or lower, depending on climate zone, right? Well, the problem is, just think about it. Think about how that works. So we've got when they use that supply only, that Honeywell, it's typically Honeywell. All other manufacturers make it as well. But, they use that damper and they bring fresh air into the return plenum. Well, that typically just runs. So even if the air handler kicks on just to bring in outdoor air, well, if you've got a 16-inch duct to the return in the hallway, and you've got a 12-inch duct to all 4 bedrooms with a return, and then you've got the longest duct in there is a 6-inch duct running all the way to the soffit. Well, when that air handler fan comes on, air follows the path of least resistance, right? Well, of course it does. Well, we saw in that table, you need 75 CFM or so. And that, granted, that, like I said, that's on a super tight house with cats and dogs and all that. But by code, that's the minimum. Well, if that air handler kicks on and air follows the path of least resistance, it's really just going to be circulating air. 90% of the air is going to be coming through that 16-inch duct. 8 of the remaining 10% is going to be coming through the 412s, and you're going to be getting 4 to 6. And my buddy that set up that Q-Fresh lab and has done testing, you're going to be getting typically 4 to 6 CFM coming from the outdoors into that unit. And then your HVAC contractor has to deal with calculations for that. I mean, to me, a standalone fan, it's literally $150 a house more to have a standalone filtered 23-watt fan that knows to shut off when it's too hot, too wet, too cold, too dry. And it will be sucking only from that supply, that outdoor air vent. It's not going to be sucking from the returns in the house as well. So I really have a problem with the way builders are doing it these days. But really the only thing you can ding them for is not having an ECM motor, because you can't really ding them for it not meeting the CFM requirements, because you're not required to test ventilation CFM. Energy Star 3.1 you are, but you know, if it's not an Energy Star 3.1 house, that's just not going to be tested.
Perfect. Let's do one more question. So baffles by design seem to provide little if no benefit since they don't align well with the soffit vent coverage area. What are the best practices when fitting the material to ensure airflow?
Yeah, so it'd be one of two ways. You would want to do those. You'd want to cut the bat. So you certainly want to install the soffit. Install the baffle so that it goes over the top plate and into the soffit cavity, at least a little, right? You really want the baffle to fill the full width so you don't have fallen into the cracks in between the baffle and the cavity. But cutting those little bats, or you'll see a lot of builders stuffing. They'll do in the spaces in between the baffle, they will stuff fiberglass bats along the top plate, so that'll keep the blown. And they'll just take a little 4 or 6 inch piece of fiberglass and roll it up and stuff it in there. It's really just some sort of mechanism to keep the blown from falling in the soffit or from blowing back out. And there's a handful of ways to do it. To me, best practice is probably the full cardboard baffle that maintains the full inch gap off the roof deck and spans the entire rafter cavity, and then has the turn down cardboard that lands on the top plate so no blown can go in. Or you saw those in my slides, you saw the bats cut to fit. That's another way to do it.